Hello students, in today's class I will be discussing about types of semiconductors. Now there are two types of semiconductors. One is intrinsic semiconductor and the other one is extrinsic semiconductor. Now first of all we'll discuss about first one, that is intrinsic semiconductor. Now intrinsic semiconductors are also known as pure semiconductors. These are pure element without any impurity added into it. Its electrical conductivity, which arises by thermal excitation of electron from the valence band to conduction band, is called the intrinsic conductivity. Now at absolute zero temperature, when the temperature is absolutely zero, intrinsic semiconductor will not conduct electricity. For example, the few examples of intrinsic semiconductors are silicon, germanium. These are semiconductors which have got 4 valence electron. The valency is 4, and until and unless we apply some external energy, this will not conduct any electricity. So I'll just draw the diagram or the crystal structure of this material. Now silicon has got 4 valence electrons, so around it there are 4 electrons. Similarly, every silicon has got 4 valence electron available for conductivity. Now so every silicon has got 4 valence electron. This is how they sit in a material. Now they form covalent bond with each another. So they share the electron and they form the covalent bond like this. Okay. So silicon forms covalent bond with one another. This is the first thing. Second one, on applying some external energy, it will conduct electricity. That means the electron will move out of this material only after applying external energy. So on applying external energy, this covalent bonds will break and electron will be free to move. So when this electron, when it jumps out of this material, what happens? If electron having negative charge jumps out, there will be a hole created over here. There will be a hole created in the place of the released electron. Now you might be hearing this for the first time, concept of hole. Hole is positively charged imaginary space. Okay, whenever a negative charge comes out of this area, there will be a space created known as hole, which has got the same magnitude that of electron and it is positively charged. So in semiconductor electronics, what we study is whenever electron is moving out, there is a space created named as hole. For example, I'll draw the band diagram, energy band diagram, to explain you this. So electrons are placed in the valence band, or valence electron are there in the valence band. Whenever we apply energy, whenever external energy is applied, this electron jumps from valence band to conduction band. This is conduction band. Now when electron jumps from valence to conduction band, there is a space created named as, this is named as hole. So the number of electron is equals to number of hole. As many electron jumps from valence to conduction band, that many holes are created. So number of electron is equals to number of holes in a valence band. Now the total amount of current. In semiconductor, the total amount of current is not only given by the movement of electron but also the current by hole. So this is electron current and this is the hole current. Okay, these are a few points which are very important. Another one is, I'll just write it over here. Another one is, intrinsic semiconductor behaves like an insulator if no external sources applied. So, intrinsic semiconductor behaves like insulator when no energy is applied. Now the last point is, electron hole pair constitute current through the semiconductor. As I've told you, current is given by electron as well as hole. So electron hole pair gives the current in a semiconductor. This is what we are talking about. Intrinsic semiconductor, which are pure semiconductor without any impurity. Okay, this is about intrinsic semiconductor. Now the most important type of semiconductor is extrinsic semiconductor or impure semiconductor. Now semiconductor with small amount of a suitable impurity. First one is suitable impurity is added in order to increase the suitable impurity increases the conductivity. Okay, it is added in very extremely small amount, so it increases the conductivity. Now the process of adding impurity is known as doping. Okay, this doping is a process of adding impurity in a semiconductor. So the element or impurity which is added as to increase the conductivity is known as dopants. So extrinsic semiconductor is also known as doped semiconductor. Okay, this is also known as doped semiconductor because impurity is added. The process known as doping, impurity is known as dopants. Now there are two types of extrinsic semiconductor. Okay, there are two types of extrinsic semiconductor. First one is N-type, second one is P-type. First we'll discuss about N-type semiconductor, or is also known as pentavalent. Pentavalent means having 5 electron as a valence electron. So for example, silicon is a semiconductor. With silicon, if you add phosphorus is an impurity, arsenic is an impurity, antimony is also an impurity. So with silicon, if we add a small amount of phosphorus as a dopant, then that becomes N-type semiconductor. So if I draw a diagram, phosphorus has 5 electron as a valence electron. Silicon has 4 valence electron. So we have silicon, and in the center we have phosphorus. So this way, okay, there is one more. Phosphorus has 5 electron, so the 4 electron creates covalent bond. Okay, the 4 electrons create covalent bond but this one electron is extra. So this fifth electron, this is the fifth electron, or which is a free electron, and it has got very small energy, that is 0.04 electron volt amount of energy, and this is used for conduction. This electron jumps from valence to conduction band. So now in this type of semiconductor, pentavalent semiconductor, the majority, this is for a single phosphorus, so there are many phosphorus in a n-type semiconductor. So the majority of charge carrier is electron or negative charge. Such a semiconductor which has got majority of charge carrier as a negative charge or an electron is known as n-type semiconductor. These have donated electrons as a donor. So this donate electron from one phosphorus to another. This electron is free to move, so this will conduct current inside the extrinsic semiconductor, which is n-type semiconductor. So electrons are in majority which are free to move. This is n-type semiconductor. Now let us discuss about second type, which is p-type semiconductor. Now p-type semiconductor are also known as Tri-Valent Semiconductor. Now Tri-Valent Semiconductor is, for example, with silicon we add an impurity of aluminium. With silicon has 4 valence electron. We add aluminium which has got valency 3. So in this case, the material which is formed, the semiconductor, is a p-type semiconductor. I'll draw the diagram. We have got aluminium which has got 3 electron. Okay, there is silicon has 4 electron. So this way every silicon has 4 electron. Okay, now over here this electron and this electron forms a covalent bond. This and this forms a covalent bond. Over here this two forms a covalent bond. But what we have over here is, we have one electron of silicon, but we don't have anything over here. So there is a hole. There is a space for electron which is known as hole, and this hole is positively charged. So in a p-type semiconductor, hole is the acceptors of electron. So the semiconductor with impurity as hole. So over here impurity is hole, is known as p-type semiconductor. It has large number of positive charge. So amount of charge carriers over here is hole. So hole is in majority. So current which is formed, which it is due to the hole, okay, in a p-type semiconductor. Now in your book there is a difference between n-type and p-type semiconductor. You can note down that thing, and also the difference between intrinsic and extrinsic semiconductor. And the conduction band and valence band diagram of p-type and n-type is also there in the book. That also please go through the book itself. So from this chapter, the syllabus is over. It's up to you only. In the next class, we'll discuss about junction diodes, which is a continuation of semiconductor diodes. That is chapter 32. This much for today. Thank you.